Hey guys, I hope you're having a great night. This is the CP video for the performance final for us going over some of the answers. Again, please remember to message me if you're watching this live and I will be able to answer more in-depth questions. I do have my phone with me. I hope by this time, you guys have looked over the CP Performance Final Review Guide and have tried to do some of the problems on your own. If not, and you're like hardcore struggling, please let me know more specific areas that you're struggling in. If it's the graphing, if it's the density, still figuring out the families, so I can make a more in-depth video on the certain topics. I have no problem doing that. I just need to know. And still not a mind reader. Haven't gained that superpower yet. So let's get started. All right. So I went ahead and I did the whole review guide. So most of this we went over in class on the first pages for most of my classes. If you're not in my class and you're watching this and you're in one of the Duluth High School's CP chemistry class, this is still the same study guide you should have gotten for the CP. Again, CP, not honors, not AP, and not gifted. So please keep that in mind, but for all CP classes, this will apply. So, performance exam, if you didn't know, 5% of your overall grade. So you still need to do well and end the semester strong. This will take place this Wednesday. All right, so density. First thing you need to do is write the formula for density. At this point, you should have remembered the triangle. At least in my classes, my students were taught the triangle. M on top, V on one side, D on the other. The formula is density equals mass over volume, and you'll see that right here. So remember, there are 3 units for density that you have for density: solid, liquid, and gases. For solids, you're going to have grams over centimeters cubed. Then for liquids, you're going to have grams over milliliters, and this does need to be in milliliters. And then gas is going to be grams over liters. And next semester, when we do our gas laws, we're going to get more into the whole why is it in liters and that kind of thing. All right, so question number 3. An unknown metal in the density lab had a mass of 14.2 grams. It has been then placed in a graduated cylinder with a 37 milliliters of water. After the metal was placed in a graduated cylinder, by this point in chemistry, you should know exactly what a graduated cylinder is. With water, the water level went from a 37 to a 39 milliliters. That's important to catch. So calculate the density of the metal. You must show your work for full credit. So remember the 5 steps. Step 1, write what you do know. Well, they told you the mass was 14.2 grams. So go ahead and write that in. Then the second thing they told you was the volume. They told you 2 separate volumes. So a graduated cylinder, and we're going to use my Shakeology cup. So let's say this was a graduated cylinder, and it's full of water. And I dropped something into it, a rock, anything, in this case, a piece of metal. The water rises. So the displacement of that from the starting point of the water, which was going to be the 37 milliliters, up to the 39 is a displacement. So that displacement is the volume of whatever you dropped into that. So 39 minus 37, you get 2 milliliters. So that's going to be our volume. And step 2 is to list our unknown. So we're trying to find the density. So write out the formula, step 3. Density equals mass over volume. Now, if we were trying to find mass, it would be mass equals density times volume. Or if we're trying to find volume, it would be mass over density. So please remember to be able to rework those, the formula into whatever you need. So step 4 is to write in the equation and solve. So 14.2 grams over 2 milliliters equals, and step 5 is to make sure you have the answer. And always in chemistry, rarely are you going to do a math problem or any type of problem that is just going to have a numerical answer. You always, always, always follow with a unit. So in this case, the answer is 7.1 grams over milliliters. So question 4 asked you basically to compare the information that you had with the 4 different types of metals that they have below, and Zn is a match for our 7.1 grams over milliliters. So hopefully you guys got the right answer on that and are able to see that. All right. Please do not hesitate to stop this video if I am going too fast, for you to make sure you're getting the right information. And also you can rewatch this video if you need some more extra time on that. All right, so determine the density of a cube of aluminum that has a length, width, and height of 2 centimeters. Please notice at this point it's not centimeters cubed. They gave you the length, width, and height of 2 centimeters, not an actual volume, and a mass of 12 grams. So you must show work again. So when you take 2 times 2 is 4, times 2 is 8, which will make your volume to 8 centimeters cubed. They told you the mass of 12 grams, and a density is your unknown, so that would be your step 2. Density equals mass over volume, so D equals 12 grams over 8 centimeters cubed. So giving you a final answer of 1.5 grams over centimeters cubed. All right, the next part is the atomic structure. Hopefully you guys have not lost your darling periodic tables, and you have those somewhere in your beautiful chemistry folders, binders, notebooks, and have not forgotten those. All right. So the first one, they give you a mass number of 4, a number of protons of 2, the number of electrons of 2, and then unknowns. So what you need to do is look at a beautiful little periodic table, and you will see that your protons are 2. Now remember that the number of protons equals the atomic number. So up at the top right here is your atomic number. So if I have 2 protons, all I have to do is look up at the top and I see that helium has 2 as well. So he has a mass of 4, so that means he's going to be an element and not an isotope. Then also, electrons equal the number of protons because we did not combine them or form any ionic charges. So for you to get neutrons, remember that neutrons, the number of neutrons, you can take the atomic number, also known as your number of protons, and subtract them from your mass number. So 4 minus 2 equals 2. So in the number of neutrons for helium, I would have put 2. He has the atomic number of 2. Now remember, your atomic numbers and protons, I cannot emphasize this enough, should always match. All right, next one. So they told you that on the second row, right here, you have a 1. So if that is my mass number, there is only one element on the entire periodic table that has a mass number of 1, and that is hydrogen. So Hydrogen has an atomic number of 1. He has 1 proton, 1 electron, and he has no neutrons. All right, third line. So they told you it was oxygen and they want you to find everything else. So find oxygen, look for the O. He's over here in group 16, period 2. So he has atomic number of 8. Look at the bottom. His mass, atomic mass, is going to be 16. Remember that the number of protons equal the atomic number, so he'll have 8. At this point in chemistry, we hadn't talked a whole lot about ionic charges when we were doing the atomic structure back in Unit 2. So he is going to have 8 electrons. So when you take 16 minus 8, you get 8. Number of neutrons. And he is also an element. So chlorine. Chlorine is our last element, the 4th row. They told you that we have the atomic number of 17 and the mass number of 36. So when you look at the periodic table, chlorine, who's in group 17, 1, 2, 3rd period down, he has an atomic number of 17. That means that he would have a number, 17 protons, also 17 electrons, because there has been no indication that we have had any ionic charge or changing or anything like that. So when you take 36 minus 17, you get 19. Now, this may differ from class to class, but for at least my classes, he has a 35.453 mass number on the periodic table. So for my kids, we would have round down to 35. So meaning that chlorine is indeed an isotope because he does not have his normal mass. Remember that isotopes are like identical twins. Maybe fraternal twins would be a better example. Fraternal twins, where even though they have the same genetic makeup and the same chemical properties and the same identity, they could be very different. One may be very, very tall. One can be very, very short. So with fraternal twins. So isotopes are just different sizes, meaning that one has an increase of neutrons, but still has the exact same number of protons. Remember that the protons give the element its identity. The neutrons add weight to it, so the atomic mass. So in this case, chlorine does not have an atomic mass of 35. He has a 36. So this is a 36-chlorine isotope. All right. Let's go down flame test. So right here is our data. So you have 4 different compounds. Lithium chloride, calcium chloride, copper chloride, rubidium chloride. So each of those would be the different colors from the flame test. Unknown A has green. So when you look over to your flame colors, you can see that the only one that had a green flame was going to be copper chloride. All right. Unknown B. All right. What is happening for the atom to cause the light to be produced? So an electron from a ground state is literally, let me back up. So when a electron is in a ground state, please remember that your Bohr models, the original placement of the electrons in the Bohr model is known as their ground state. So the first ring, the first bullseye target for my classes, is 2. The next ring, your next energy level, has only 8 places for electrons. Then after that, 8 as well. So when an electron, so let's use this one as an example. When an electron takes in energy, light can have 2 types of energy, the photons. It takes in a photon and literally gets excited. And he no longer stays where he normally is, but jumps to a higher energy level in order to be able to produce that color when you stuck your stick with the liquid into the flame. I hope all of you were able to at least see a flame test and know what I'm talking about when we took our sticks and stuck them into the flames. Okay. So, excitation. Please keep that in mind, that the photon is taken in by the electron and jumps to an excited state, and that this process is called excitation. So identify compound A, so copper chloride. Identify compound B, lithium chloride. All right, metals, nonmetals, and metalloids. So on your periodic table, you should have had been discussed where metals, nonmetals, and metalloids are. On the periodic table that's in front of you right now, everything in this beautiful peachy color is going to be a nonmetal. Everything in this purple right here is a metalloid. Everything in this puke sage green, don't know why anyone would like that. Puke green right there, that is going to be a metal. So, first one, metals. So can they conduct electricity? Yes, they can. All right. Are they malleable, brittle, or either? They're malleable, which is mendable, moldable. Something real cool fact, I think at least, when you have completely raw 100% sodium, it comes like in this like almost like clayish brick, and it looks really weird. And when you first see it, it's going to be like this sandy whitish color. But when you cut into the actual clay of sodium, like pure sodium, what happens is it is this shiny, metallic, beautiful color. But because sodium is in group 1 on the periodic table, right here, he's like crazy reactive. And he's so reactive that literally the air that's around him reacts with him and causes this white, dull looking color and has this ionic bonding effect, which is totally rad and cool. So most of your extremely reactive metals in group 1 and 2 have to be contained in oil so that they don't react and they can stay stable. So just cool fact of the night. But anyhow, so for metals, whenever I'm trying to study and I remember those, I remember about sodium and that he was shiny and beautiful when I saw him. So really shiny, and that yes, they are very reactive. Some of them are very, very reactive with acids. They're great to play with. Anyhow, nonmetals. Nonmetals do not conduct electricity. When they are actually a solid, they are brittle. They have a very dull appearance to them, and they do not react with acid. Metalloids. Remember that these are the hybrids. These are the mutants of the periodic table. They have a little of metals. They have a little non-metals. They're just made up of either ones. Both, they're the hybrids. So They can either conduct electricity or not conduct electricity. They could be malleable, they could be brittle. So this entire row on your answer key is either. It could be either, which is cool because metalloids have their own uniqueness. All right, periodic table. I enjoy doing this. I like the periodic table. I like how it's structured, everything about it. So here we go. Question A. So give the family name of number 2. So that's an alkali earth metal. So number 2 is located in group 2. And it's important to remember each of the groups because you're going to be given an element and be asked where it is on the periodic table, whose family it is in, and you're going to have to remember that and write it in. So this is the alkali earth metal. Just so let's go over the others real quick. So when we look at this, remember that in group 1, starting with lithium going down, are going to be your alkali metals. Then group 2 is your alkaline earth metals. Then in the funky yellowish color in the middle, these are going to be your transition metals. Then the yellow right here is going to be your other metals. Then going down the staircase here. Now, a great way to remember which ones are metalloids going down the staircase, it has to touch a full side of the staircase going down, the metalloid does. And aluminum is the only one touching the staircase on its sides that is not a metalloid. It is another metal. So boron, silicon, all of these are going to be your metalloids. Then your nonmetals are your purples up here, halogens, and noble gases. Then your rare earth metals are down here below. Please remember that hydrogen is not actually going to be a part of the family group for group 1, but he is a part of the noble gases. Not noble gases, sorry, brain fart. Non-metals, and he is with carbon, nitrogen, oxygen, phosphorus, sulfur, and silicon. Okay. So, sorry, I was drinking water a second ago. So for B, give the energy level. So all you have to do for energy levels is count the periods. So that your rows for number 9. So number 9 is located right here. So you just count down 1, 2, 3, 4, 5. So he's in the 5th energy level. So when we say energy level, we're talking about the Bohr's model. When we drew out those crazy rings going around with our electrons, each of those rings are a separate energy level. So for number 9, he is going to be on the 5th energy level. All right, C. Give the valence electrons of number 5. So number 5 is located here in the 13 periods. So please remember that when you do your valence count, your transition metals are not involved in this. So group 1, right here at the first, has only 1 valence. Group 2 has only 2 valences. Then jump over and go to group 13. Group 13 only has 3 valences. Group 14, 4 valences. Group 5, 5 valences. Group 16, 6 valences. Group 17, 7. Group 18, 8. And that is all of them. So, the only ones on the periodic table of all the family groups and all the groups who are completely stable, happy, content, are your noble gases. Please remember that noble gases have 8 valence electrons. So because of this, they have succeededly grasped the octet rule. And since they have grasped and mastered the octet rule or the duet rule, because helium is the one that has only two possible ones, so they have mastered their stability. So they're happy. They're content. They're like, I don't want to play with you. So groups 1, 2, 13, 14, 15, 16, and 17 are the most reactive back and forth with each other when you form your ionic bonds. So just by the way, transition metals are involved, but you have a higher amount with groups 1, 2, 13, 14, 15, 16, and 17. All right. I'm starting to notice by doing these videos, I say all right a lot, which is aggravating. D. Is number 7 a metal, nonmetal, or metalloid? So number 7 is right here. He is not touching that cute little line right here at all. So he is a non-metal. Now 6 is a metalloid. Remember that 5 is aluminum. He is not a metalloid, even though he's touching those lines. 4, 3, non-metal. 10, 9, 8, 2, and 1 are metals. So please be able to identify and clearly distinguish which ones are which. All right, give the oxidation number, the charge. Guys, I cannot express this enough to you guys, and I have my cute little board to even write it out. So, oxidation numbers equals ionic charge. In the world of chemistry, in the world of science, mind-blowing. They have sometimes multiple names for different meanings for the exact same thing. So give the oxidation number, the ionic charge of 4. So let's look at 4. So please remember that group 1 has a positive 1 charge because it has 1 valence electron. Group 2, 2 positive charges, 2 valence electrons. Group 13, 3 positive charge, 3 valence electrons. Group 14, remember that's your 4. He can either go either way. He's going to be a positive or negative 4. Group 13, 14, 15. 15 starts going down. So he has 5 valence electrons, and he's going to have a negative 3. Group 16 is going to have a negative 2. And group 17 right here, which has our darling little 4 right there, he's going to have a negative 1 charge because he has 7 valence electrons. Remember that it is easier to bring 1 valence electron over than it is to take 7. So what's happening is this, and I'll bring up exactly which ones are which. So we have fluorine. Fluorine has a valence with 7. And I'm just going to draw the outermost ring of the valence electrons. Yes, I do 100% know that this is not the full valence electrons. Full electrons for Bohr's model. And let's say fluorine, darling, decided to react with sodium. So what is happening is this. Fluorine has a 7 valence electron, so it's the outermost circle. Valence electrons are only having to do with the outermost circle of your element. And sodium has 1 valence electron, even though he has more inside the rings. Remember, I didn't draw the whole Bohr's model. I know that. This is just a demonstration. These are just the valence electrons. So what's happening is ionic bonds, ionic charges, are formed because ionic bonds give up, transfer an electron. So what is happening is sodium is literally losing his electron, goodbye, and giving it to fluorine for him to be whole, for the octet rule to apply. So when sodium loses his cute little electron, he no longer has an equal amount of protons and electrons. So let's look at the periodic table. Sodium is an 11. So he no longer has 11 electrons. He has 10. So he's a positive 1. And fluorine, so let's look at fluorine, has a 9 electrons because he has 9 protons. So fluorine does not have 9 electrons anymore. He has 10. So when you compare 9 positive protons to 10 negative electrons, you form a negative 1. So that is how you get your positive and negative ionic charges. All right, F, which number represents a halogen? So what the question is asking you to please identify where halogens are on the periodic table. Group 4. All right, G, give the block in which number 2 is located. So what they're talking about is blocks are these. Please remember that you have your S, P, D, and F blocks. These have to do with your electron configuration and your orbitals. In my classes, I showed you the 3D images of the atom of an element structure and what orbitals actually look like and how they form together within the orbital cloud. So, S blocks are literally groups 1 and 2. P blocks are on the other side. That's your 13, 14, 15, 16, 17, and under helium, group 18. Then your transition metals happen to all be your block D. And then your rare earth metals at the bottom are your F blocks. This is what is referred to as your blocks on your periodic table. So let's locate number 2 on the periodic table. So the question is asking us, which block is it in? It's S. It is your S block. Okay. Water break. I don't know why, but my water tastes like crazy chlorine today. BT Dubs, if you guys need a Christmas present from Ms. D, water filter. I would be very happy. All right. Which element has the largest atomic radius? So that's compared to numbers 2 or 7. So remember that atomic radius? I'm trying to see if I still have... Oh, I do. All right. So remember that your atomic radii, that when you're on the smaller groups, like group 1, group 2, you're larger. So remember that these are kind of like magnets, that your electrons are attracted to your protons, and that they happen to be in their own electron clouds, or energy levels within the electron cloud. So the more electrons on the outside, so the higher your valence electrons, the tighter it goes in. So you'll notice that your darling noble gases in group 18 are very small. And that's because they have a full octet. And that magnet effect is bringing in the radius size. Now, this does not mean they lose their weight. I wish this was true. In my classes, we talked about a girdle. how girls wear a girdle sometime for prom or whatever. So it doesn't change their weight. It can make their figures a little different. So that's just exactly what is happening. In groups 1 and 2, this is because they're larger because they have less of that magnetic pull in because they have less electrons on the outside. So that's talking about the rows going across. Now, every time you go down a period, you add another energy level to your element. So as you go down the periodic table, it gets larger as well. So when you compare 2 versus 7, they're both in the exact same period, the exact same row. So 2 is going to be bigger. All right. Which element has the highest ionization? Is it going to be number 5 or 6? So 5 or 6. Let's see if I have my other chart that I want. I thought I had this ready. Give me another second. Boom. Ionization. It increases as it goes up, and it increases at an angle as well across. So the question asked us, is it going to be 5 or 6 have a greater ionization? So as you look at this image, 5 versus 6, which was going to be right here, lithium versus silicon, and silicon is going to be larger. Aluminum versus silicon. Silicon is going to be larger than your aluminum. Now remember that with ionization, as you go up, like from bottom to top of your periodic table for each of the columns, you increase. As you go from left to right of your periodic table, it increases. For the record, it is the opposite of your radii. Kind of cool. All right. All right, so according to the octet rule, will number 9 form an anion or a cation? So, super simple. Cations are going to be your metals. They are going to hold your positive charge. They gave up the electron. Anions are going to be negative charge. They're going to be your nonmetals, and they took in that beautiful electron. So, number 9 is here. Boom. So he's going to be a cation. All right. Let's keep going through this. I know I need to go see my mom, see how she's doing from her hip surgery tonight. And I'm sure you guys want to get done with this video. All right, so graphing. In my classes, we're going to physically do this graph together. Walk us through. I need you to try it on your own. I do want you to fill in the correct information if you have not done that and talk about it some tonight. So graphing. So for my classes, we talked about the dry mix, DRYMIX. So dry mix is just a cute little saying to help you remember who goes where. So y-axis, dependent variable. X-axis, independent variable. Okay, so the independent variable goes on the x-axis. This is the variable that the scientist manipulates. He controls. He makes the decisions of, are we gonna time Timmy at 5 seconds for how fast he can go, 10 seconds, and 15 seconds? Those would be independent variables, something the scientists control. I want to see how many fish live at 100 feet in the lake, 200 feet in the lake, 300 feet at the lake, and then measuring how many there are. So those are known as our independent variables. Our dependent variables go on the y-axis, and these are the things that are measured. So how many fish we're at the 100 feet mark in the lake, the 200 feet mark, or the 300 feet mark. How much, the measurability of that moment. It's also, it 100% depends on your independence. So all of you want to be growing up and driving and have your independence. So you have to make healthy decisions. It's manipulate. And then for your dependent variable, you're dependent on your parents. And I'm sure how much money they give you, it's going to depend on how awesome you are. So you're still dependent. All right, here we go. So in this example, a student wanted to see if there's a correlation between the number of times he could jump on his foot and the times he held his breath. So each time he jumped on his right foot, he compares his data to jumping on his foot without holding his breath. All right, so let's talk about this. Holding his breath is the independent variable. It's the thing he controlled. Then jumping up and down is what he's trying to measure while he's holding his breath. So independent variable, holding breath. Dependent variable, number times jump on one foot. So the control. Please remember that your control is going to be the thing you measure your data to, the thing you hold constant. So in this case, in the paragraph, it says he compares. So that's a really good indicator when you're reading the paragraph. Oh, so he's going to compare something. That the next thing that comes after that word is going to be your control. So he compares his data to jumping on his foot without holding his breath. So that means that jumping on his foot without holding his breath is your control. So you need to graph this data. We're going to talk about 6 and 7 in class. So describe the relationship between the number of jumps and times. So the direct, as one increases, the other increases. Indirect, as one increases, the other decreases. All right. Bonding. Here we go. I love bonding. All right, so we have sulfur as our example element. So I hope by this time you have seen it on the periodic table. So what group does sulfur belong to? So when you look at the periodic table, you will see that sulfur belongs to group 16. He is also in the non-metal family. So how many valence electrons does he have? And we've talked extensively in this video, so I'm going to go quicker through this because I have talked about valence electrons. I have talked about the energy levels. So by this time, you may even just want to pause the video and see if you can get this section right on your own. That's my mummy. See, guys? Told you. Hold on. Hey, so I'm filming a YouTube video and I'm almost done and I'm heading your way. Because you're live with me right now. Okay, bye. All right, mom's doing well, guys, for those of you who knew about her surgery and stuff. So I'm going to go check on her pretty soon. So how many valence electrons does sulfur have? It has 6 valence electrons. It's in group 16. That's fine. How many energy levels does sulfur have? Remember to count your periods. So literally it's in the 1, 2, 3rd period down. So that means that he's going to have the 3rd energy level. So oxidation, also known as your ionic charge. Please do not forget that. All right. He is going to have a -2 ionic charge because he's in group 16. Group 17 has the -1. Group 15 has the -3. So sulfur literally is going to be gaining electrons. So sulfur, let's look at this. Sulfur, darling. Again, this is just, I know I'm drawing out a Bohr's model for just valence electrons. So I can explain things. I did not draw out the whole Bohr's model. So if he has 6 valence electrons, that means that sulfur wants 2 more to come to him for him to be full. So that means, think about it this way. Is it easier to take 6 people to a friend's house or to bring 2 people over to your house? Probably just bring 2 over versus 6. So he is going to gain, when he forms that ionic relationship, gain 2 electrons. All right, so write out a formula for the, write the formula for the compound formed between aluminum and sulfur. So we have aluminum, who is a positive 3, and you can look at your periodic table. He falls into group 13. So we have aluminum, who is a plus 3, and we have sulfur, who is a negative 2. Guys, does the charges match? Do they cancel each other out? If you're saying no in your head, you're thinking right. So think to yourself, what do I need to do next? If they do not have the exact same ionic charges, where it's a positive 3 with a negative 3, what do? You need to do your crisscrosses. So all you need to do, circle just the numerical number, the representation. Now, this is to help you figure out how many you need. This does not mean that you're actually moving the charges around. So I want people to realize that, please and thank you. So what this is saying is sulfur is going to need to have 3 of them. So he's going to need 3 negative sulfurs. 3 negative 2 sulfurs. So he's going to need 3 sulfurs that have a negative 2, which equal a negative 6 overall charge. Then aluminum, you're going to need 2 aluminums with a positive 3 charge. So 3 times 2 is plus 6. Now, does plus 6 minus 6 equal 0? If you're thinking yes, awesome. So when you write this out, aluminum 2, sulfur 3. I am not switching charges. Literally, what is happening is this. Aluminum, needs 2 of himself with a positive 3 to make it a positive 6. Sulfur needs 3 sulfurs of a negative 2 to equal a negative 6. 3 times negative 2, negative 6. So that is what that is. So the answer is aluminum 2, sulfur 3. This is an ionic formation. It is a metal with a non-metal. When you write out his name, you're going to write aluminum. Remember that you always leave your cations as is on the periodic table. Now, if your cation is a polyatomic, which is on the back of the periodic table, you are going to leave the name as is as well. If he's a polyatomic and he's an anion, then you also leave him as is. You never change a polyatomic name whatsoever. Carbonate, sulfate, any of those on the back of the periodic table. Now, the second word was sulfur. Remember that we take sulfur and we make him sulfide. All we did was add the IDE at the end. We made him from a sulfur to a sulfide. So his ionic full name, Aluminum sulfide. The group of elements would sulfur bind to in a 1-to-1 ratio. Literally what this question is asking is this. Who has the opposite charge of him? So if he has a -2 charge, that means the opposite of -2 is a +2. So look at your periodic table. Group 2 is the only one with a +2 charges. So that is how to answer that question, or to think of it for a 1-to-1 ratio. Because remember that with ionic charges, you want no extra electrons running around. You just want them all to cancel each other out with your positives and negatives, your cations and your anions, and make them a 0 charge. All right. This is the video just for the CP Performance Final. I'll do some other videos this week for more extensive stuff. For my classes, I know this for at least, if you are still strongly struggling in an area, like hardcore struggling, we have our chemistry support videos already on our e-class for every single unit. I went ahead and moved them to the top of our content area, so that literally includes atomic structure, decay radiation decay, alpha beta particles, isotopes, half-lives, if your electrons, everything you can possibly think of with this entire semester is made on videos on our e-class. Please make sure to look under content, chemistry support videos. All right, guys, I hope you have a fantastic day, night, whatever is happening. Please let me know tomorrow if you have any questions and everything like that. Take care. Bye.